Hey there, I'm going to show you how to use FlatCAM to convert Gerber files to G-code files so that you can mill your circuit boards on a CNC mill. Eagle users can already do this with a plugin called PCB G-code, but FlatCAM will work for any PCB software package provided it follows the Gerber and Epsilon drill format correctly. There are 4 steps to do a conversion. Import Gerber and Epsilon files, create geometry, create toolpaths, and export G-code. The first step is to import your Gerber and Epsilon drill files. I'll use the top layer of my Arduino project as an example. I'll also import the Epsilon file. Step 2 is to create geometry for each of those files, and also for a board cutout. I'll select the Gerber file and go to the Selected panel. There's a lot of stuff here, but right now we only care about the isolation routing section. This board requires a 1/64 inch flat end mill, so I'll enter the decimal equivalent here. We only need one pass, so we'll leave these other settings alone. Then I'll click Generate Geometry. This generates geometry around the traces and pads and also creates a geometry object back in the project panel. I'll also make geometry for a board cutout. My tool for this operation will be a 1/32 inch flat end mill, and I'll set a margin of 0.05 inches larger than the components. The gap size is how large to make the breakaway tabs, but I don't need those because I stick my boards down with tape. So I'll set the gap size to -0.1 and I'll click Generate Geometry. Back in the project panel, I now have geometry objects for the traces and board cutout. Now I'll make geometry for the holes. The Mill Holes feature makes it so you can cut multiple hole sizes with one end mill. I'll select all the different drill sizes, enter the decimal equivalent of a 1/32 inch flat end mill, and click Generate Geometry. Back in the project panel, I now have geometry objects for the traces, board cutout, and holes. Step 3 is to turn them all into CNC toolpath objects, which I can then turn into G-code files. For each geometry object, I'll select it, then go to the Selected panel and enter the cut depth, feed rate, and tool diameter. So first I have the traces. I'll use a cut depth of 0.05 of an inch, a feed rate of 15 inches per minute, and a tool diameter of 1/64 of an inch. Then I'll click Generate to make a CNC toolpath. There's the toolpath in blue. Now I'll do the same thing with the board cutout. I want to cut all the way through, which is 0.063 inches for my boards. I want a slow feed rate of 6 inches per minute because we're doing the entire depth in one pass, and I'll use a 1/32 inch tool. Then I'll click Generate. Now I'll create a toolpath for the holes. I'll select the holes geometry object, set the depth to 0.063 inches, feed rate to 15 inches per minute, and tool diameter to 1/32 of an inch. Then I'll click Generate. Back in the project panel, we now have CNC toolpath objects for the traces, board cutout, and holes, and you can see them represented in blue on the right. Step 4 is to export these toolpaths as G-code files. First I'll do the traces. FlatCAM doesn't have a place to specify spindle speed, so I have to add it manually. So I'll type S16500 in the prepend section, which will tell the spindle of my other mill to spin at 16,500 RPM. Then I'll click Export G-code to save my file. I'll add the tool size into the file name for reference later, and I'll use the .nc extension so my other planned CNC software will recognize the file. I'll do this same thing for the other 2 CNC toolpath objects, including adding the spindle speed command. That's it! My Gerber and Epsilon drill files have been converted to G-code files. Now in my CNC software, this is other plan, I'll import all the files. Great, that looks awesome. Now I'll choose the tool I used when I generated each of the files, which is conveniently in the file name. That's it. We're ready to start milling.